Hello and welcome back. In this lecture, we are going to talk about non-homogeneous equations. In our previous lectures, we talked about homogeneous equations with constant coefficients. Now we are going to talk about non-homogeneous equation. And we were talking about second order. So the general form for non-homogeneous equation is ay double prime plus by prime plus cy equal to fx. So this time our fx is non-zero and abc we are considering as constant because we are talking about equations of constant coefficient. So this is our general form. We also write this equation as Ly equal to fx when this operator is not very important to us. Okay, so we want to find out a general solution for this equation. So what we will do is, first we will write down the associated homogeneous equation. Here the equation, by substituting fx equal to 0, we call it associated homogeneous equation. So this is associated homogeneous equation to equation 1. And then we will find out the solution to this associated homogeneous equation, which we already learned how to do in our last videos, and we will call that as YC, the complementary solution. Then we want to find out one particular solution. This particular solution you can find out by guess or by any other method, just one particular solution which satisfy our differential equation, and in that case our general solution will be given by the sum of these two, the complementary solution and the particular solution. This is going to be our general solution to our equation number 1. Okay. Saying that this is general solution means if we have any other solution, then that would look like this. Okay. So here we are going to talk about the methods to find out the particular solution, because we already know how to find out the complementary solution, right? So the first method we are going to discuss is method of undetermined coefficient. And in this lecture I am going to talk about the same examples we have in lecture notes so that you don't get confused. So you can use your lecture notes side by side to have a reference. Okay, so first thing, when can we apply this method? When can we apply the method of undetermined coefficient? So this method can be applied when our fx is a linear combination of finite product of one of these, finite product of these functions, which I am going to write down now. The first one can be x power n, or you can say any polynomial in x. Second one is e power any natural number times x, so e power nx, any exponential function. And the third one is cosine kx or sine kx, where this k can be any real number. Okay, so if our fx is linear combination of finite product of these functions, then we can use the method of undetermined coefficient. Okay, let's talk about this method a little bit. So here are the rules. First rule is so we are assuming that we already have the complementary function and our fx. So we know what is our yc and fx. So rule 1 is, suppose no terms of fx or its derivatives have a duplication in yc. So by that I mean that no term in fx or its derivative satisfy the associated homogeneous equations. In that case, our guess for yp is going to be linear combination of all independent such terms. Like if we have x square as our fx, okay, and this x square doesn't satisfy the associated homogeneous equation, then x square, x and 1 are the linearly independent terms. So we will take our yp as ax square plus bx plus 1. Okay. Let's see one example and then it will be more clear to you. So our first example is, so we want to find the particular solution. Find the particular solution for this ODE, y double prime plus 4y equal to 3x square. So here we are asked only to find the particular solution, but if we are using the method of undetermined coefficient, we need our complementary solution first. And to find the complementary solution, first we write the associated homogeneous equation, which is y double prime plus 4y equal to 0. We write our characteristic equation. So here I am assuming that you already know how to find the complementary solution. Even then I'm just writing it down quickly. Then our r is equal to plus minus 2i. In case of complex roots, our yc is given by c1 cosine 2x plus c2 sine 2x. So this is our complementary solution. And our fx is equal to 3x square in this case, right? So note here that fx and its derivatives are constant multiples of following linearly independent terms. So we are not bothered with the constant multiple. We are just looking for the linear independent terms. So first one is x square, which is involved in fx. The second one is x. When you take the derivative, you will get 6x. So we are not talking about the constant multiple, we will just take x and 1. And none of these appear in YC. So this is important point. None of these appear in YC. So if none of these appear in YC, it means we can apply our rule 1, and by our rule 1, our YP, the general form of YP is going to be ax square plus bx plus 1. Okay. Okay, so in the notes we used 3x cube, so that you don't get confused, I will keep it x cube. X cube. So our general form of YP is 3x cube plus bx square plus cx plus d. Okay, this is the general form of our particular solution. Now if this is a solution, we are calling it particular solution. If this is a solution, this must satisfy our ODE, right? So let's find out. So if we want to plug in the equation, we need y double prime, right? So let's go ahead and find out that. So yp prime is 3ax square plus 2bx plus c. Taking the derivative again, we get 6ax plus 2b, right? Now this should satisfy our equation, which means yp double prime plus, what was the equation, plus 4yp should be equal to 3x cube. Let's see. So we want yp double prime plus 4yp. So 6ax plus 2b plus 4 times yp plus bx square plus cx plus d. Now let's collect the coefficients of similar terms. Coefficient of x cube is 4a. Coefficient of x square is 4b. We have this 4 multiplied over here. Coefficient of x is 6a plus c, and the constant term is 2b plus d. And as discussed, they should be equal to 3x cube. Now we can compare the coefficients. So x cube coefficients must be equal. So 4a should be equal to 3, which gives us a should be equal to 3 over 4. X square coefficient, which is 4b, is equal to 0. It means b is equal to 0. Coefficient of x, which is 6a plus c, is equal to 0. Substitute the value of a. So 2 to the 4, 3. So our c is equal to -9 divided by 2. And the constant term, which is 2b plus d, is also equal to 0. b is equal to 0, which gives us d equal to 0, right? So we got the value of a, b, c, d. Putting back into our yp, we get our particular solution is equal to 3 over 4 x cube. b is 0, so there is no x square term, minus 9 over 2x. This here is our particular solution. So this is how we find out the particular solution using the method of undetermined coefficient. Let's see one more example of similar type. Before that, let me tell you one more rule. It's very simple one. So suppose you have fx, f1x and f2x. Ly equal to f1x and f2x is your non-homogeneous equation. Then to write your trial solution, to write your yp, it's going to be yp for f1 plus yp for f2. Okay, let's see how. Our next example is we want to find out the general solution for the equation y double prime minus 3y prime plus 2y equal to 3 times e power negative x minus 10 times cosine of 3x. First step is always to find out the complementary solution. So we write down our associated homogeneous equation. Write down the characteristic equation. For double derivative we replace by r square. For first derivative we replace by r equal to 0. Find the roots of this equation. You can use either quadratic formula or you can factorize. Here I am going to factorize. So r minus 2 times r minus 1 equal to 0. So roots are 1 and 2. So our complementary function, complementary solution will be c1 e power x plus c2 e power 2x. Next, our fx here is equal to 3 times e power negative x minus 10 times cosine of 3x, right? So now we are going to write down the terms involved in fx and its derivatives. Or I should say linearly independent terms which are involved in fx and its derivatives. So for the first term e power negative x, if you take the derivative you will get negative of e power x. If you take the derivative again you will get e power negative x. So only one term. For the second term you can have cosine 3x or sine 3x, and then it starts repeating. We are not considering any constant multiple. So these are three linearly independent terms, and none of them appear in the complementary solution. None of these appear in YC. So our YP, our particular solution, will look like a times e power negative x plus b times cosine 3x plus c times sine 3x. The first term over here, this is corresponding to 3 times e power negative x, and the last two terms are corresponding to the part of fx which is negative 10 cosine 3x. Okay. Next step is always to plug in yp back in your equation to find out values of your constant a, b and c. So let's plug this back in our equation. So yp double prime minus 3 times yp prime plus 2yp is going to be the left hand side. Okay, so for that first we need to calculate yp prime and yp double prime, the double derivative. So here if we take the derivative we will get negative a e power negative x plus 3 times 3b sine 3x. Derivative of sine x, derivative of cosine is negative sine plus 3c cosine 3x. If we take the second derivative we will get a e power negative x minus 9b cosine 3x plus, minus 9c sine 3x, because derivative of cosine is negative sine. We will substitute in our equation and we will get okay, so you need to substitute in the equation. So yp double prime is equal to a e power negative x minus 9b cosine 3x minus 9c sine 3x. So this term is corresponding to your yp double prime. Then we have negative 3 times yp prime, so negative 3, So first term, if you multiply with negative 3, you will get plus 3a e power negative x plus 9b sine 3x minus 9c cosine 3x. This term is corresponding to your negative 3 yp prime. Then we have plus 2yp. So 2 times a e power negative x plus 2 times b cosine 3x plus 2 times c sine 3x. So this term here is corresponding to your 2yp. Okay, now let's collect the coefficient of similar terms. So what is the coefficient of e power negative x here? It's a plus 3a plus 2a. What is the coefficient of cosine 3x? It's negative 9b minus 9c plus 2b. And the coefficient of sine 3x is negative 9c plus 9b plus 2c. And this should be equal to our fx, which is 3 times e power negative x minus 10 times cosine 3x. So from here we got 3a plus a is 4 plus 2 is 6. So 6a, which is coefficient of e power negative x. So what we are doing over here is we are comparing the coefficients. Comparing or equating the like terms. So we got 6a is equal to 3. The coefficient of cosine 3x is equal to minus 9c minus 7b equal to negative 10. Coefficient of sine is 9b minus 7c equal to 0. From first equation we got a is equal to half. Let's calculate b and c from our last two equations. Okay, so multiplying the second equation by negative 1, we get 7b plus 9c equal to 10 and 9b minus 7c is equal to 0. Okay, I am leaving this for you, and you can see that value of b you will get 7 by 13 and value of c will be 9 by 13. So your particular solution is going to be 1/2 e power negative x plus 7 over 13 cosine 3x plus 9 over 13 sine 3x. And then you can write your y as sum of your complementary solution plus the particular solution. Let me copy what was your complementary solution. So over here is your complement. Oh, sorry. This is our complementary solution. I'm going to copy and paste. This is our complementary solution plus the particular solution which we just calculated over here. Can't fit it there, so this is our general solution. So this was the case when our YC doesn't have any duplication with the fx term. In the next video we are going to see the case when there is a duplication. Okay, practice some more problems and I'll see you in the next video. Bye bye, take care.